So the modern way to do footsteps in video games is with what are called, at least in Unreal Engine, animation notifies. You would call a notify to play a sound every time the foot of your character touches the ground in your character's animation. But this is a first-person game, and we aren't using animations, so we'll have to make a workaround, or essentially the way it's done when you have no character. So what we want to do is more than just play a footstep noise every time we're walking. We want to actually be able to change the footstep noise based on whatever material we're walking on. So to do that, we need to go to Project Settings, so Edit Project Settings, and we need to go to Physics, and we have to find Physical Surfaces, which is all the way down here. And we can create different surface types. We're only going to be working with 2 because if you know how to do 2 separate ones, you can add as many as you want. So we're going to do tile and grass. And we can go ahead and close that. If you want more, just keep adding them. So let's go to Content, and let's make a folder called Physical Materials. And we can open that up, and we have to create physical materials. So right click, Physics, Physical Material, and we just choose this right here, and hit select. And I'm just going to call this PM for physical material, tile, and duplicate it and call this one PM, grass. So we'll open tile, and there's a lot of options here, but the only thing we're worrying about right now is sound. So we just need to change the surface type to tile and grass, but they're not showing up. So let's try hitting save on everything. I'm gonna try closing it and reopening it. I'm gonna go back into the project settings, make sure they're still there. And that worked. So we can just go ahead and select tile, save, and then open grass and select grass and save. And that's the only things we need to do with those, so we can go ahead and close them. So let's just take our floors here, and I'm just going to use these blocks that we have, and I'm going to make this one a tile ground. We should have a material that, because it comes with the starter content for tiles, and I'm just going to use this ceramic tile checkered. That looks good. And for this one, I'll use grass. And we gotta add, assign the physical materials. So if you, in the physics tab, we have, oh, not in the physics tab, I'm sorry, the collision tab, we have physical material override. And I'm just going to find our tile. And then for the grass, I will find grass. So now these materials have these physical materials assigned to them, but nothing will happen because we still don't have our sounds imported. So similar to the jump scare, I found some great concrete and grass footsteps. I found them on freesound.com. They are not mine, but I was allowed to use them. But these, the sounds I downloaded were a compilation of 6 sounds each. So I put them into Audacity and split them up to have 6 different footsteps. So if we go into sounds, I'm going to make a new folder called footsteps to organize it. I'm going to hit import, and I have all of these. So we have footsteps concrete, and then 01, 02, 03, 04, 05, 06. So I actually have 7 concrete ones and 7 grass ones. Oh wait, no, I'm sorry. We only have 6 of each because this first one is the compilation one. So I'm going to just import these 12 files. And the reason I like having multiple of each is that so you can play them at random, so it won't be the exact same footstep sound every single time. So let's create a cue for the tile. So I'm going to right click, go to sound cue, and I'm going to call this tile footstep cue, and open it up. And I'm going to add all 6 of these into the queue. just like that. And we have this random node right here. And we want to have 6 inputs. It's 5, 6. And we'll just go ahead and put these all in. So it'll randomly choose one of these every time the cue is played, and just plug it in like that. Now these are a bit quiet, so I'm also going to turn the volume multiplier up to 1.5, and I'm just going to do this exact same process for grass. So doing this process of having 6 different footstep sounds and playing them at random is not a mandatory step. You could just have one and just plug it into output like normal, but having the randomness definitely will make it sound a little better. But if you do only have one audio effect, if you made your own or you could only find one, you can add a modulator right here and put it through the modulator. And this will allow you to get a random pitch. So the pitch and the volume can kind of play at different random values within this minimum and this maximum, which is actually pretty nice. And on top of this randomness, I'm actually going to include the modulator for even more variety. And I'm just going to leave it at the default of 0.95 to 1.05 for both. Actually, I'm going to make this 1.45 to 1.55, and then just have this volume multiplier at 1. Doesn't really matter, it should give you the same result, I believe. I'm going to copy and paste this modulator to the tiles as well. Alright, so now we have our audio all set up, and I can press play over and over again to kind of create the footstep sound. And we kind of have this walking sound effect, which sounds really good. So let's go to our character and actually create the footstep sounds inside there. So let's go in here and let's create a function called play footstep. And we want to check if our velocity is greater than 0 because we don't want to play the footstep when we're not moving. So we will, the character movement, get velocity, and then get the length, vector length, and let's just check if this is greater than 0, and you can also make it like, greater than 10 to just create a little buffer there in case you're moving so incredibly slowly you still don't think you should play footsteps. We also want to make sure we are not falling, because if we're falling, our velocity will be quite above 0, but we still don't want to play the sound, so we'll add an AND boolean right there. And then we'll get is falling, which comes from character movement, and we will get a not boolean to make sure we are not falling. And we just need to call a line trace straight down to see what material we are on. So we can't use that line trace one we have right here because that comes out of the camera, so we'll just have to make another one. So line trace by channel, and we're just going to get our location for start. So it's just going to start wherever we are, and it's going to end at our location plus a vector, which we split. And the z is going to be our location minus 100. So it'll just call a line trace to right below our actor, and it'll detect what material we are walking on. So we want to call an if statement for return. So only if it hits something will we continue off this true path. We can break the out hit result. And we have this node here called physical material, or physmat, and we can actually get the surface type, and we will use that to play our sound. So play sound 2D. This one we can actually play sound at location if we want, and play it where our actor is. So get actor location. but it doesn't matter too much. And for the sound we play, we will get a select node, and the sound we play will be based off our surface type. So we have a default, a tile, and a grass. So the tile will just search for tile footstep queue, and a grass, search for grass footstep queue. And we can also select default, so this is the one that will play if we have nothing, no physical material assigned, like this one right here. And we'll just set that to tile as well. And I'm thinking maybe actually instead of the actor location for the location, we can get the impact point. So it'll play it right on the ground rather than in the middle of our character, which is probably a smarter option. All right, so let's go into our event graph, and it's kind of a mess. We should probably organize this a bit with comments. But essentially on the begin play, we need to create a timeline. And we're going to call this footstep TL for timeline. And we want to make this 1 second long, and we need to add an event track. And we'll just call this footstep. So we can add a keyframe at time half a second and value 1. And another keyframe at time 1 second and value 1. We can press these icons to kind of zoom into what we're looking at here. And now if we look at the event graph, we have this new output called footstep, and this path will be called every time we come across one of these keyframes. So we come across at half a second and 1 second. And if we choose loop, this means every single half second this keyframe will be called. And we also want to select autoplay. And this is great, so we'll just play from start, right in begin play. And off of footstep here, we can just call our play footstep function. And let's try this out. So let's go ahead and play. And we're walking on grass right now, so we should hear the grass footstep when we start walking. And when we get to the tile, it should start playing the tile footstep. So that sounds really, really good. We only have one issue right now, and that's if we start sprinting or crouching, it plays at the same rate when it should be playing a lot slower. But while we're crouching, if we're sprinting, it should play faster. Oh, and also if we go on a material with no physical material, it'll still play the tile because we put that as our default. But we want to make it go faster when we're sprinting and slower when we're crouching. So if we go to our character and our input axis move forward, I'm going to just start commenting these out now because it's long overdue. So we're just going to call this movement. And we just need to adjust the timeline's play rate based off our movement. So, excuse me, I'm just going to move this to the left a bit and increase our comment size. And right before we get started, there's one thing we need to fix in headbob. Now that stuff is going to happen after it, we have to make sure the return is always called. So let's make a return node. Let's plug these both in, and we also want this function to return if we go off this false node right here. So now no matter what happens in this headbob function, this will continue. So creating this timeline will actually create a variable for us. So we have this footstep timeline right here. We can drag this out. Under the components tab, I should have mentioned. And what we're going to do is just call set play rate. And we're going to put this up here as well. And for the play rate, we need to get a map range unclamped. And our value is going to be our velocity. We can type get velocity and then get vector length. And this is going to output our speed, which if we go into movement, we can see right here. So our sprinting is 500, our walking is 250, and our crouch speed is 100. So the in-range A and B are going to be our crouch and walk speed. So if we get our movement, get crouch speed and get walk speed, this gives us a range from 100 to 250. And for our walk speed, this will output our outrange B, so we want that to be 1, so it stays the same as what it's set to be. And if it's our crouch speed, I'm going to put it at 0.7, which will only play at 70% rate. And since this is unclamped, it means it will continue to do the math even if we go above our range B, which is our walk speed, which we will, because we'll be sprinting. So it can actually output a number greater than 1. So if we start sprinting, it'll do the math for us and start sprinting or playing it at a faster rate. Okay, so let's test out the timing right here. So if we're walking, it plays at a normal rate. And if we're crouching, it plays slower. And if we're sprinting, it plays faster. And that feels really good. And lastly, before we go, let's also change the volume so that when we're crouching, it's softer, and when we're sprinting, it's louder. So if we go back into our play footstep function right here, right where we play sound at location, we have this volume multiplier, and we're just going to use the same technique. So we're going to map range unclamped, and these values are going to be the same, so I'm going to go to the event graph and copy and paste the ones we just made. So our vector length is our value, crouch speed is in range A, walk speed is in range B, and it's going to be 0.5 for crouching and 1 for walking, which will make it a lot louder for sprinting. So we can test this out as well. So it should be normal when we walk. And then if we crouch, it should be half as quiet. And if we sprint, it should be louder. Right before we wrap this up, let's add this to jumping as well, because it should definitely make a noise when you land. Right now it's just silent. So if we go to L1 character, event graph, and create a our function on landed, or event, I mean. On landed, event on landed. This will call every time we land, and we just want to copy and paste everything in this play footstep after checking for this, because we don't have to worry about our velocity or is falling. So we're just gonna Control C and graph, Control V. Oh, that's a mess. Just gonna start getting things out of the way. Oops, sorry, excuse me. And just gonna, there we go. Okay. And then on landed, plug that in. Same line trace. We just check if we hit it. We check which sound to play. And I'm gonna get rid of this map range clamped. And we just want to make the volume multiplier 2, just so it's a bit louder when we jump. So let's try that. Yeah, that sounds great. So now we have our footsteps in place, and it works really well. It sounds really great. And that's it for this episode. I will see you in the next one.